The break statement literally breaks the loop at its position and makes the flow control jump to the next statement outside the loop, as you see here on this flowchart. As a result, any statement after break, operation 2 in this case, will not be executed. For this reason, break statement should be always associated with a condition that determines when the loop will be terminated. In this example, the break is located between increment operation and the print statement. Let's test this code. The output shows that the break ended the loop in the first iteration at I equals to 0 and n equals to 1, without executing the inner print. Now I'm adding a condition. Let's say if n is larger than 100, then break. The loop was ended when n was 127, which is larger than 100. Notice that the print statement after the break, which is operation 2 here, didn't print the values of I equals to 6 and n equals to 127. Break is extremely useful in mathematical and numerical computations when a series of iterations are to be stopped when a specific or critical value is reached. You will see that in a coming lesson in this chapter about a numerical method for solving nonlinear equations. Continue makes the flow control skip all operations after it by jumping to the next iteration. Unlike break, it doesn't cause the flow control to terminate the loop. This example uses the same previous code, but by using continue instead of break. When we run the code, we see that the inner print statement stopped at I equals to 5 and n 63. However, the print statement outside the loop printed that the loop was exited at I equals to 9 and n equals to 1023. Continue is usually used in numerical computations when a group of equations or functions are to be skipped after a specific condition, while another group is to be continued in calculations to the end of the loop. Else statement can also be added to the Python loop. It is added to the end of the for loop or a while loop in exactly similar way in the if structure, as we saw in the last chapter of conditions. The operations added to the else block are executed only if the loop ends normally. As you see here, if the statement or looping condition is false, the control flow goes directly to else operations and then goes to the next statements after the loop. So as you see in this example, we added an else statement or else block to the for loop to print that the loop ended normally. Let's run this example. So as you see here, since the loop continued normally to the end, the print statement in else block displayed the message, the loop ended normally. In case the loop doesn't end normally because of a break statement, the else block will be skipped. Let's check that by adding a conditional break statement. Let's say if x is larger than 3000, break. The last value of x printed is 256. So as you see, there's no print in here saying the loop ended normally. By replacing the break statement by continue, as we see here, let's run the code. The message, the loop ended normally, has been printed because the loop continued to the end without interruption. Practically speaking, unlike conditions, else is not used frequently with loops. It could be useful when one or more operations should be connected to the end of the loop when it ends without any interruptions.